Kendall and Katie, the science ladies.
Kendall and Katie, the science ladies.
Kendall, Katie, Kendall, Katie, Kendall, Katie. Kendall and Katie, the science ladies.
Acids and bases.
Hey, my science crew. Today we're going to be learning about the wonders of acids and bases. Hey, litmus paper. Why so blue? Come on, man. That's a basic joke.
Acids and bases.
Consider the following. Buffers. Buffers are solutions that can resist pH change upon the addition of an acidic or basic component. It is able to neutralize small amounts of added acid or base, thus maintaining the pH of a solution relatively stable. Buffer solutions have a working pH range and capacity which dictates how much acid or base can be neutralized before pH changes, and the amount by which it will change.
Acids and bases.
First, let's start with the safety precaution. Never, ever, identify acids or bases by the way they taste or feel. That'd be stupid. Yeah, really. Don't get crazy. These Sour Patch Kids symbolize the physical properties of acids. Acids are really sour tart, and they turn solutions into conductors. Can I get a true? True. Consider the following. Some of the acids are very dangerous. Sulfuric acid, for example, is highly corrosive. It can eat away almost every metal.
Acids and bases.
Now let's start out talking about bases. Kendall, not that kind of base. This bar of soap symbolizes a base. Bases are really slippery. They smell good and you can use them in the shower. Just kidding, don't use them in the shower. Don't get crazy. You could probably die. Probably. Bases are also bitter. Like a pickle. A pickle's bitter? I don't know. Consider the following. Most organic acids, those obtained from living things, are weak and generally harmless. In fact, we eat them in the form of fruit and vinegar. Acids and bases are both electrolytes as well.
Acids and bases.
Now time for the chemical properties. Acids turn blue litmus paper red. Bases turn red litmus paper blue. Turn methyl orange to yellow. And turn phenolphthalein to purple. Acids react with active metals to produce hydrogen and react with carbonates to produce salt, water, and CO2. Kendall, don't drop them! Consider the following. Bases are often found in cleaning and gardening products. Here are some common household acids. Vinegar, aspirin, lemons, cream of tartar, and grapefruit. And here are some household bases. Baking soda, ammonia, not pneumonia, Kendall, ammonia. Oh. And hydrogen peroxide. Consider the following. If a base dissolves in water, it's known as something else. Most bases are not soluble, but if they are referred to as alkalis. Let's talk about molecules.
sound like 00.
It shows that acids produce hydronium ions and bases produce hydroxide ions. Second, there's the Bronsted-Lowry model. It shows that acids are hydrogen ion donors and bases are hydrogen ion acceptors. And lastly, the Lewis model. It shows that acids are electron pair acceptors and bases are electron pair donors. Consider the following. The fizz in soft drinks is produced by adding carbonic acid. Strong acids are acids that have the ability to ionize or donate the hydrogen ion in an aqueous solution reacting with water. However, the strength of an acid does not equal its concentration. Anyways, the more an acid ionizes, the stronger it is. Acids that are extremely strong, or 100% ionized, are not in reversible reactions. They're usually one way. Strong acids produce more hydrogen, H+ ions, than weak acids. The 6 strong acids are 1. Hydrochloric acid, 2. Nitric acid, 3. Sulfuric acid, 4. Hydrobromic acid, 5. Hydroiodic acid, and 6. Perchloric acid. Weak acids have less production of hydrogen ions, H+. They don't fully ionize in a water solution. The reverse reactions are more successful than the forward reactions. Most organic acids are weak acids. The 4 weak acids are 1. Acetic acid, 2. Formic acid, 3. Hydrofluoric acid, and 4. Hydrocyanic acid. The letter K with the subscript A represents the relative strength of the acid. Strong bases are bases that are strong. They dissociate 100% into the cation ion. Hydroxides of group 1 and group 2 metals are usually considered strong. The 6 strong bases are lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. That was right. Okay. Now, most bases are not strong. They are, in fact, weak. Weak bases do not make hydroxide ions by dissociation. Instead, they react with water to generate hydroxide ions. The 4 weak bases are 1. Ammonia, 2. Methylamine, 3. Pyridine, and 4. Ammonium hydroxide. Now, what is pH? pH is the symbol for the logarithm of the reciprocal of hydrogen ion concentration in gram atoms per liter. It's used to express the acidity or alkalinity of a solution on a scale from 0 to 14, where less than 7 represents acidity and more than 7 represents base or alkalinity. Pure water is right smack in the middle, at 7. Here are some pHs of some common household items. Tomato juice has a pH of 4. Bleach has a pH of 12. Detergent has a pH of 9. Grapefruit has a pH of 3. Lemons have a pH of 2. Cream of tartar has a pH of 5. Vinegar has a pH of 3. Baking soda has a pH of 8.2. And aspirin has a pH of also 3. Ammonia has a pH of 11.6.
Woo! Let's go. What you know about the scale? Acids and bases, and don't forget solutions. Time, don't waste it. No need to dumb it down and over-explain what we're doing. Now hop on the pH scale and get the train moving. Oh yeah, the pH, the pH, the pH. That's the scale that differentiates an acid from a base. Scale starts at a 0 and goes to 14, while a 7 means it's neutral. Knowledge is beautiful. Acids free hydrogen, bases free hydroxide. When they are mixed with water, ain't no reason to doubt. I know acids are below a 7. They say sour bases above a 7, and they're soapy like the shower.
What you know about that? pH, pH. What you know about that? pH, pH. Acids, they can start a fire, but the base could put it out. Gotta know the scale before you panic, so you do not scream and shout. What you know about that? pH, pH. What you know about that? pH.
Earlier I talked about keeping the train moving. I know you got lots of questions, well I got the solution. The solution is a solute dissolved in a solvent. Solvent is what dissolves. The solute's where it does it, like salt inside some water. Water is the solute, salt is the solvent. Now a solution is produced. Now whether acid or base is determined by the pH, and for the record it's a neutral. Knowledge is beautiful. Yeah, an acid can burn you up, but a base can burn you up too. Know the composition of a base or an acid, and I guarantee it doesn't burn you. They're both different, but lots in common, cause they do relate. At extremes they can be hostile, at neutral they're innate. They're both reactive in nature and soluble in H2O. Acids can exist as a solid or liquid or gas, let's go. But please don't underestimate the bases, cause they're your biggest ally. They'll change an acid's property to completely alkaline.
What you know about that? pH, pH. What you know about that? pH, pH. Acids, they can start a fire, but the base could put it out. Gotta know the scale before you panic, so you do not scream and shout. What you know about that? pH, pH. What you know about that? pH.
Barium and cesium, potassium and sodium, strontium, rubidium, lithium and calcium. Get your bases right, get your acids tight. Get your bases right, get your acids tight. Sulfuric and nitric, chromic and boric, phosphoric, fluoroboric, hexafluorophosphoric. Get your bases right, get your acids tight. Get your bases right, get your acids tight.
Back to your spot.
Kendall, this time.
Go.
Kendall.